PU2 champions, your first pre-board exams are very close, and at this point of time, it is very important to do smart study. So in this video, I am going to discuss the most important repeated questions from all the chapters of your chemistry PU2 syllabus. Okay. So now if you have already done with the syllabus, make sure that you do proper revision of these questions because there's a high probability that these questions will be asked. And if you have not completed all the chapters or you're half prepared or if you have not prepared anything, then also make sure that you complete at least these questions and go to the exam because there's a high chances that these questions will be asked and you will perform better. Okay, so now let's get started with the video and see what all chapters we have first of all. So if you have seen, the first chapter is solutions. Oh, sorry, 1 second. So the first chapter is solutions. Then we have electrochemistry, chemical kinetics, DNF block, coordination compounds, haloalkanes, alcohols, aldehydes, amines, and biomolecules, right? Now, if you see, some of these chapters are highlighted in yellow. So these are those chapters, or these are those chapters highlighted in yellow, which I have told you to do to get at least 60 plus out of 70. And you will be getting content for all these chapters in my channel. Okay. So now I'll go chapter by chapter and I'll tell you the most important questions from all these chapters. So let's see the first one, that is solutions. So from solutions, you need to prepare very important Henry's law, Raoult's law, okay, with their mathematical expression. Okay, you need to know the formula as well and the terms, what do they mean and all. Next, difference between ideal and non-ideal solution with examples. Examples are very important here. Next, positive and negative deviation with examples. Then why vapor pressure decrease on addition of solute. Okay, reasoning question can be asked here. Then why boiling point increases on addition of solute, why freezing point decreases on addition of a solute. Here you should know the reason and you should also know the graph for all of them. Next is what are azeotropes, then what is maximum and minimum boiling azeotrope. And here also you need to learn the examples. Okay, next is what is molarity and how does it vary with temperature. Then what is osmosis and reverse osmosis. Here also you should know the practical application, that is desalination of water. And also with osmosis you should know about isotonic solution. Okay, isotonic, then you have hypertonic and hypotonic solution. Right, all their definitions and examples you should know. Then what is abnormal molar mass and Van 't Hoff factor, how to calculate the Van 't Hoff factor, and then numericals on colligative properties. Okay, so all the 4 colligative properties you should know the formula of RLVP, delta TB, right, and delta TF and pi, that is osmotic pressure. Moving to the next chapter, that is electrochemistry. So this chapter I have not completed in my channel, so I'll just tell you the list of the questions that you can prepare. But for all these questions you can find the video where I have discussed the most important questions from the solutions chapter. There you will find all these questions answers and you'll find many more questions as well. Now coming to electrochemistry, the first thing you need to know is Faraday's law. Okay, see, Faraday's law, Kohlrausch's law and its application. Then Faraday's law with the formula you should remember. Formula is important. Next, the cell reactions of the Daniell cell, then working of this one, that is standard hydrogen electrode, its cell reaction and cell notation. Then construction and working of hydrogen oxygen fuel cell, this is important question. Then what are primary and secondary cells and their examples. Anode and cathode reaction for the batteries like dry cell, lead cell, fuel cell, and your corrosion of iron. Next, what is corrosion and why corrosion is an electrochemical phenomena. And then you have problem on calculation of EMF of the cell, delta G and equilibrium constant. Okay, we'll see some problems. So what you can do is go to the model papers and just solve the numericals part. Okay, the first, these are some numericals that I have taken from the model question paper of 25-26. So these 2 questions are on the calculation of EMF of the cell. These 2 questions are for the calculation of delta G. Next, we have these 2 questions for the calculation of equilibrium constant. Then you have calculations of conductivity and molar conductivity, and then you have questions on Faraday's law. Okay, so just do these numericals and practice it thoroughly. Next, coming to the third chapter, that is chemical kinetics. So here first thing that you should know is factors affecting the rate of the reaction, very important question. Then derivation of 0th law, derivation of first law, first integrated equation. Then derivation of one more derivation is there. Okay, so that I'll show you. Then we have draw the graph of potential energy versus the reaction coordinate showing the effect of catalyst on the rate of the reaction. This is important. Next, what is effective collision and the factors responsible for effective collision. Then show that the half-life of a first order reaction is independent of its initial concentration. Then you should know Arrhenius equation, its graph, and all the terms of Arrhenius equation. Then the Boltzmann distribution curve for T and T plus 10. And then you have numericals on first order reaction and numericals on Arrhenius equation. Here one more derivation is important. Okay, I have mentioned it already. So derivation of zeroth and first order, and derivation of first order in the gas phase. Okay, now gas phase has been asked in the last year pre-board exams. Okay, so please make sure that you prepare. This is very rare question and we generally get confused with first order derivation and first order gas phase derivation. Okay, both are different things, so prepare them thoroughly. Next, we'll move to DNF block elements. So here the very important question is the manufacture of potassium dichromate, then manufacture of potassium permanganate, then what are interstitial compounds, their characteristics, magnetic properties of the transition elements, and you also need to know the magnetic moment. You should know the formula, how to calculate that one. And then there are certain elements whose magnetic moment can be asked, so you should know the basic formula. And very important is to remember here the electronic configuration, right? Okay, next, interstitial compounds already have discussed. Then why transition elements form a large number of complex compounds, this is important. Then copper 1 is unstable and it undergoes disproportionation reaction. So why does that happen and what is the reaction, that you should know. Then why transition elements act as good catalyst, why they show variable oxidation state, why the second ionization enthalpy of copper is very high, why copper 2 plus ions are colored, why scandium 3 plus are colorless whereas V3 plus ions are colored. So this is all because they have unpaired electron. So you don't have to worry here, any question can be asked. If something is colored, they have unpaired electron. If there is something which is colorless, that means it does not have unpaired electron. Next, with reference to the first row transition series, name the metal which shows maximum number of oxidation states, and then between Ti2 plus and V2 plus, which has more number of unpaired electrons. Right, so these questions you can easily answer if you have remembered the electronic configuration. After that, you have to calculate the spin-only magnetic moment for certain ions, that you should prepare. Then from lanthanides and actinoids, what is lanthanide contraction, its causes and consequences, actinide contractions and the cause for that. Study of actinoids is very difficult, give 2 reasons, 3 reasons, very important question. Make metal and its application, where it is used. Then name a member of lanthanide series which shows +4 oxidation state, so that is your cerium, so that also you should know. Moving to the coordination compounds questions, the first one is the Werner's theory and its postulates, then IUPAC nomenclature, geometrical and optical isomers. Okay, optical isomers. Then the hybridization geometry and the magnetic property of COF6 3-. Then you have limitations of valence bond theory. Then certain reasoning questions are asked like FeH2O6 3+ is strongly paramagnetic, whereas FeCN6 3- is weakly paramagnetic. Explain. Similarly, write the energy level diagram for the crystal field splitting in tetrahedral and octahedral complex. Next, how does the crystal field splitting configuration for D6 in weak field and strong field ligand of octahedral complex? Next, with the help of structure, explain the synergic effect in metal carbonyls and how it affects the MCO bond strength in such compounds. Next, NiCl4 2- is paramagnetic while NiCO4 is diamagnetic, though both are tetrahedral. Why? Now again, all these questions you can find in the most important questions video of coordination compounds. I have covered it in detail, so you can watch that and get answers to all these questions. Moving to haloalkanes and haloarenes. So the first one here, mechanisms, SN1 mechanism, SN2 mechanism, then name reaction, Woods reaction, Fittig reaction, Finkelstein reaction, Schwarz reaction, Friedel-Crafts reaction, and Grignard reagent and its formula. Next, you have definition of certain compounds like chiral carbon, enantiomers, racemic mixture, what is racemization, then reaction of alcoholic KCN, AgCN, alcoholic KOH, aqueous KOH, then you have KNO2 and AgNO2, right? Next, all these reactions for fill in the blanks type questions will be asked. Any reactions can be asked, so you can just practice this one. Next, why aryl halides are less reactive? Three reasons, very important question. What is chirality and condition for a molecule to be chiral? Then Saytzeff rule, and then you have reaction of alcohol with thionyl chloride. That is the most preferred method for the preparation of haloalkanes. What is the reason behind that? Then 2-bromopropane and alcoholic KOH, what will be the reaction? And when you have 2-bromopentene with alcoholic potassium hydroxide, what will be the reaction? Para-dichlorobenzene has higher melting point. What is the reason? What are freons and what is its harmful effect on the environment? Next, moving to alcohols, phenols and ethers. So here also we have a lot of name reactions. Coles reaction, Riemann-Tiemann reaction. Cumene process is very, very important. Mechanism of hydration of alkenes to alcohols. This is also very important. Dehydration is more asked, like in the last 3-4 years. Dehydration of alcohols mechanism has been asked number of times. So please prepare this one definitely. Mechanisms of alcohols to ethers. Acidity of alcohols, Williamson ether synthesis, cleavage of ethers, then we have picric acid, reactions with copper and Lucas reagent. Okay, moving to the next question, next chapter, aldehydes, ketones and carboxylic acid. Here also we have a lot of name reaction. First, very important, HVZ reaction, Itard reaction, Wolff-Kissner reduction, Clemenson reduction, Gattermann-Koch reduction, haloform reaction, aldol condensation, Cannizzaro reaction, Rosenmond reaction, Stephan reduction, cross aldol and decarboxylation reaction. After that you have Tollens reagent and Fellings reagent. Acidity order question can be asked. Mechanism of addition of HCN and addition of ammonia and its derivatives. So that table is given for ammonia. That table you should prepare. Then why aldehydes are more reactive than ketones? 2 reasons, 2 marks. Then why carboxylic acid is more acidic than phenol? This is also important question. Next, you have give the chemical equation for the conversion of propane nitrile into the corresponding ketone by using phenyl magnesium bromide and write the name of the product. So basically the reaction of I can say nitriles with Grignard reagent. Okay. Next, aromatic carboxylic acid does not undergo Friedel-Crafts reaction. Give reason. Then you have between methanol and ethanol, which will undergo aldol condensation, which will not undergo. Like that questions can be asked. Then case study questions like A reacted with B, B reacted with C. So from this question bank, I have solved all the case related questions. You can watch that and definitely prepare those case based questions. Okay. Now moving to the amines chapter. So first one, here is the preparation of para-hydroxyazobenzene, that is the coupling reaction. Then pKb of aniline is more than that of methanamine. Give reason. Next, general equation involved in Gabriel thalamide reaction, very, very important question. Then carbyl amine reaction, again super important question. Then the basicity order, okay, in the aqueous medium, that is also next important question. Then you have what is Hinsberg reagent and how do you distinguish primary, secondary and tertiary amines by Hinsberg reagent. This is important one. Then Hoffman bromamide degradation and the reaction by taking butanamide as an example. So basically Hoffman bromamide degradation. This is also super important reaction. Then here is a case based question. An aromatic compound A on treatment with aqueous ammonia and heating forms a compound B, which on heating with Br2 and KOH forms compound C. The molecular formula is C6H7N, and then you have to write the IUPAC name and the compounds A, B and C. Next, give reason. During reduction of nitro compounds to amines, scrap iron is used and solubility of aliphatic primary amines decreases with the increase in molar mass of amines. So these questions are important. Next, moving to biomolecules. Here, first of all, what is the tertiary structure of protein and write its two major shapes. So here basically you have to write about fibrous and globular protein. Right? So what you have to do, you have to remember their difference. Next, write a reaction to show that glucose contains 5 OH groups. So here all the 5 reactions that has been done to derive the structure of glucose, those 5 questions or 5 reactions can be asked in the form of 5 questions. So please prepare that. Okay. Next, zwitterion and its structure, important one. Then what is peptide bond? Howard structure of maltose protein present in hair. Then you have what is reducing sugars, non-reducing sugar, example, optically inactive amino acid. This is important. One vitamin which is stored in liver and adipose tissue. Then what are anomers? Give an example of a keto sugar, limitations of the open chain. Okay. Next you have Howard structure of lactose, denaturation of protein and water soluble protein, example. Next you have essential amino acids, difference between DNA and RNA. Then what is oxidoreductase enzyme, and name the enzyme that catalyzes the hydrolysis of maltose into glucose. Next, source of vitamin K and non-reducing sugar, invert sugar. These are all definitions you should know. Name the storage polysaccharide present in plants, monomer unit present in starch, components of the starch, and two difference between amylose and amylopectin. Okay, so students, these are the most important questions. Now I definitely know that all of you want this PDF, so I'll be giving this PDF in my WhatsApp channel. The link of the WhatsApp channel is there in the description section. And for the 6 chapters, that is solutions, chemical kinetics, coordination, haloalkanes, alcohols, and aldehydes, please watch the most important questions video. Okay, that will give you an idea of what type of questions are asked, and if you do those questions, then definitely you can get 60 plus. And still, if you have any doubt, let me know in the comment section. I'll definitely clear it. And thank you so much for all the love and support you're showing. So all the best. Just study smartly at this point of time, and you can ace this exam. Thank you so much, and take care.